We're going to take a few minutes here to talk about electric fields, and this is how charges kind of affect or interact with their surroundings. So this is a useful way to understand how charges will act in a given space. So an electric field, the electric field, one way of thinking about it is it describes the force that a +1 or a +1 Coulomb charge would feel at different points. So where the field is, in other words, where the field is strong, it will feel a strong force or a large force. Where the field is weak, it will feel a weak force. So now there's no actual charge there. The charge doesn't need to be there. It's just, imagine I did put a charge here. How much would it feel a force from whatever is creating that electric field? And this will make a bit more sense when I give you some illustrations here. But this is the big picture. So in order to illustrate an electric field, we illustrate it with electric field lines. And so the rules for drawing lines, and then again, this will make sense kind of once you see an example, but I want to lay them out here so you've got them as a reference. Lines always start at a positive charge or infinity. So they could start way off, infinitely far away. They will always end at a negative charge or infinity. So either they come in and stop at a negatively charged object, or they'll go out to infinity. Lines will never cross each other or intersect. And they will always point in the direction a positive charge would feel a force, and they are closer where the field is stronger and farther apart where the field is weaker. So here's an example of how we would draw that. So for example, I have a positive charge here. Now, like we said, electric field lines always start at positive and positive or infinity, and they always end at negative or infinity. So I'm going to draw a little box around here. This is just to show that my lines aren't stopping randomly, that they're going kind of outside this box. So this isn't contained in here. This is just like, imagine this is a piece of paper, and I'm drawing these. So my lines, because I have a positive charge here, they're all going to start at my positive charge. And then I just think at every given point, where's a positive charge going to feel a second positive charge, what direction will feel the force? So if I have one a little bit above, it's going to be pushed upwards. And it's going to still be pushed upwards and still be pushed upwards and still be pushed upwards until it gets out to infinity. So in other words, I have one line that goes up. In the same idea, if I have an object or a positively charged particle just kind of corner diagonally here, it's going to keep feeling pushed away from the positive charge like that. If I have one here, it's going to keep being pushed that way. And so now I'm going to start adding these arrows to show the direction of these lines. Going to get pushed like that, pushed like that, and you can see that what I end up getting, and if you just imagine all these places, or I can, talk through it with you in class, it's always getting pushed away in straight lines away from the center here, because that's what a positive charge would feel a force on. And so you'll also notice when we're closer to the positive charge, these lines are closer together. When I'm farther away, they're farther apart. So the field is stronger when I'm closer. The force is stronger when I'm closer, and that makes sense if you remember, because the force is equal to K Q1 Q2 over R squared. So if the distance is shorter, the field is stronger. A negative charge will look very similar, but we remember that lines end at negative. And if we imagine this positive charge, it's always going to be pulled in towards the center here. So we will also have a bunch of these straight lines pointed straight towards the center, like so. And that's sort of what we have for just a basic single charge by itself. We can also do this for multiple charges. So if I sketch out a positive charge and a positive charge, well, if I'm over here, it's easy to imagine because a positive charge over here is going to be pushed to the left by the first guy and by the second guy. So it's definitely going to go like that. Same thing with the right side over here, definitely pushed this way. Now, if I was up here, what's going to happen is I'm going to push kind of diagonally this way because this charge 1 is pushing it, off in that direction, and charge 2 is pushing it really strongly up. And what we'll end up getting is sort of a curving line like this. And we end up getting a lot of kind of curved lines along these lines. And this is something that is a lot easier to kind of just talk through in person if it doesn't sort of make sense to you why this would work. It's also something that if you play around with, sort of becomes more clear. But we can imagine if I had a charge here, it's going to be pushed sort of downwards, but also because it's closer to this first one, it's going to be pushed a little bit diagonally. So we end up with this, and then you have this space in the middle where actually it won't get pushed at all either way because it's right dead center. Then lastly, just as another example, if we have a positive and a negative, well, anything in between, it's easy to see why it would just get a positive charge would just get pushed straight to the right. If I'm up here, I'm going to mostly get pushed away, but also pushed up because I'm really close to this guy, until a certain point that I get pulled in towards the negative. And we end up seeing that same sort of result. And I get this sort of ball, footballish type shape that just keeps going out farther and coming in. And this is a real sloppy sketch. If you want a better example, you can look them up online or ask me in class and I'll draw a better one. That should be inwards. And then on the very ends, I've got one pointed out and one pointed in. So that's the basics of electric field lines. If you have any questions, feel free to ask, but this is something that I know will have a couple activities that will help clarify it as well.